In this video, we would study about area of a parallelogram. But first of all, what do we mean by area? Area is the magnitude or measure of the planar region enclosed by a single plane figure. Now, I am drawing two squares. As you can see clearly, both of them have same shape and size. We know that if two figures have same shape and size, then they are called congruent figures. And if two figures are congruent, and if they're superimposed, they will cover each other completely. Hence, we can say that two congruent figures will always have same areas. But the converse is not true. That means if I draw a rectangle and say that the side of this square is 6 centimeters and the length of this rectangle is 9 centimeters and its breadth is 4 centimeters, then we know that the area of this rectangle is equal to 36 centimeter square, and similarly the area of this square is equal to 36 centimeter square. Both of them have equal areas, but still we know that they cannot be congruent because they have different shapes and sizes. Hence, if two figures have same areas, they need not be congruent. Now, let's come to our next concept. As you can see here, we have a trapezium ABCD and a parallelogram EFCD. Here you can see that they have one side in common, CD, and both of them are resting on that side. That means this trapezium stands on CD and also this parallelogram also stands on CD. Hence, we say that trapezium ABCD and parallelogram CDEF are on the same base DC. Also, if I now join DE, I am joining D to E. Here we have AF to be parallel to DC. Hence, we can say that the trapezium ABCD lies between the parallel lines AB and DC, and also this parallelogram EFCD lies between the parallel lines AF and DC. Hence, both of these quadrilaterals lie between the parallel lines AF and DC. Therefore, we say that trapezium ABCD and the parallelogram EFCD lie between the same parallels, and also they are resting on the same base. Hence, both of them are on the same base and between the same parallels. Now let's focus on parallelograms. Here we have two parallelograms, parallelogram ABCD, ABCE actually, and FBCD. Both of them are on the same base BC and lie between the same parallels AD and BC. So we have a theorem which says that if two parallelograms lie on the same base and between the same parallels, then their areas are equal. Therefore, we can say that area of parallelogram ABCE is equal to area of parallelogram FBCD. Now let's prove this statement. If I assume this angle to be x, angle AFB is x, then this angle would also be x. Angle EDC is also x because angle AFB and angle EDC are corresponding angles between the parallel lines BF and CD, and the transverse is FD. Similarly, if this angle is y, then this angle will also be y. Again, both of them are corresponding angles between the parallel lines AB and FC, and the transversal is AE. And also FB is equal to CD. FB is equal to CD because FBCD is a parallelogram. Therefore, we have proved that triangle AFB is congruent to triangle ECD by AAS test. Now what is the area of parallelogram ABCE? It is area of parallelogram ABCE. It is actually equal to area of quadrilateral FECD plus area of triangle AFB. And what is the area of parallelogram FBCD? It is area of quadrilateral FECD plus area of triangle ECD. Now here in both these equations you see this term, the first term is equal, area of quadrilateral FECD. And now that we have both these triangles to be congruent, triangle AFB is congruent to triangle ECD, and we know that congruent figures have same areas. So area of triangle AFB is equal to area of triangle ECD. So if these two are equal, then these two equations are also equal. Hence we can say that area of parallelogram ABCE is equal to area of parallelogram FBCD. Hence we have proved that if two parallelograms are on the same base and between the same parallels, then they will have equal areas.